Well, I had a couple of problems sent to me, so what I'm going to do is we're about to finish up Unit 3 anyway, because I don't think we go to 3.7. And 3.6 is the continuation of 3.5, product and quotient rule. So let me pull up the homework, and we will do a few problems to warm up, and then we'll do the problems that were sent to me and see what that looks like. Let's start off with something simple like this. Now, what I would suggest is do it both ways. Let me get back to where I was. Hold on. Get to my whiteboard and pull it up. Okay, didn't save it. Great. Hold on. Thought I saved it. Must have hit new. There we go. Now I pull it up. Do it both ways. Two ways to do it. Morning. All right, there's two methods. See if you come out with the same thing.
Is that d minus n plus, yeah.
Say again?
D times n prime plus.
First times derivative of second plus second times derivative of first. Was that a sneeze or a cough? No sneezing. So what's the derivative of 9x to the fourth? 36x to the third. 9x squared minus 18. So over here, we've got 9x plus 3. And then 3x what? Plus x cubed minus 2 times 9 period. And distribute this, we get 27 x cubed plus 9x squared plus 9x cubed minus 18. Got some similar terms there. So 27 plus 9 is dang old 36, isn't it? Yeah. Look at there. Plus 9x squared minus 18. Is it the same? Yeah. So you shouldn't get any wrong on this one, on this test, but you can check yourself. Heck, gone. Got so much stuff and got about this much room up here. The chair won't even fit through it. Oh, all right. Let's do a nerd. Let's do the quotient rule, and then after we do that, we'll do the homework problems that somebody sent. Let's find the quotient rule. What? I don't know. We may go to unit 5 and skip unit 4. Let's go with this one. Let me snip it good. Any 80s music fans in here? Oh well, I thought it was a good year. Good decade for music. Y'all don't talk much anyway, so I don't know why I'm asking you. Not like y'all are gonna talk. Why would we do that? I know, it'd make the class a whole lot more interesting.
Every time you save something on this computer, does it do stuff after you log off?
Yeah.
Yeah. All right. There's 2 ways to do this one. We'll do both ways.
I know. I know. It's all the done. It's gonna happen.
with this change.
There's the two ways. You can either start with the product rule by bringing the 5x plus 1 up to the top. When you do that, that makes the positive 1 that's there turn into a negative 1 as an exponent. And then use the product rule. And then the quotient rule, you just do denominator times numerator prime minus numerator times denominator prime over 5x plus 1 squared, or denominator squared. Why did I put brackets on the quotient rule but not over here on the? Because of that negative. So you need to take your highlighter, a red highlighter, or of course yours would be pink. I don't have that luxury of pink, so that red right there means you have to do what with that negative? You have to distribute it with whatever product you get. And that will get you. So you need to make provisions to not let it get you. So that's why I put the brackets. So let's go back to this one.
If you continued solving,
Huh?
you continue solving, right?
Yes, that's what I'm fixing to do next.
Okay.
G prime of x is equal to 6x minus 1. The derivative of 5x plus 1 is, chain rule, negative 1, 5x plus 1 to the negative 2 times what? 5. Derivative of what's inside. That's the chain rule. Plus 5x plus 1 to the negative 1 times, what's the derivative of 6x minus 1 or 6x plus 1?
6.
6. Now you might want to make a little note here that this is the chain rule. From here to here is the chain rule. Because why? It's got parentheses and it's got a what? Exponent. And that 1 is out front. So negative 1 times 1 is negative 1. 5x plus 1 comes down. Negative 1 minus 1 is negative 2. And the derivative of the green is 5.
Is there any reason why you wouldn't be able to use the quotient rule? No?
Just quotient rule is whenever you have a division, that's the only time you can use it.
Is there any circumstance where you would need to use like the chain method in the product rule?
Well, yeah, right here.
Well, instead of the alternative of using the quotient rule or the other one.
They're just they intermingle. You can have one and the other. It doesn't matter. You just got to be able to see it. You can have the chain rule in the quotient rule. You can have the chain rule in the product rule. You can actually have the product rule and the chain rule inside the quotient, the product rule and the quotient rule inside the chain rule. It all depends on how complicated the problem is. But yes, you can have all of them intertwined. So, g prime of x is equal to 6x minus 1. And this is all multiplication, right? Yeah, it's all multiplication. So I'm going to take this 5, and I'm going to multiply it by this negative 5, and I'm going to bring that negative 5 out here to the front. You see what I'm doing? Because I want to try to isolate that 5x plus 1. Why do I want to isolate? Why do I want to isolate that? Okay, it's not working now. Okay, now it's working. 15 minutes later. That 5x plus 1 is raised to the what? Negative 2 power. So I want to isolate it so I can bring it what? Down. So I'm going to bring this 5 and this negative 1. That's 5 times negative 1. I'm going to bring it out to the front. Negative 5 and then 6x minus 1 and then times 5x plus 1 to the negative 2 plus that 5x is to the what? Negative 1. So you can bring it down. So I'm just going to rewrite this as 6 5x plus 1 to the negative 1. And now I'm going to bring the x terms to the negative power. I'm going to bring them down. So that's going to be g prime of x is equal to negative 5 times 6x minus 1 over 5x plus 1 quantity squared plus 6 over 5x minus 1 to the first power. Now, what's the problem? We need a common denominator. Well, that means we got to multiply this by 5x minus 1, right? So I got to multiply this by 5x minus 1.
Don't you mean plus 1?
Say again?
Don't you mean plus 1?
Yes. Yeah. Did I? Oh, yeah. I'm sorry. Thank you. Wife mode. All right, 5x plus 1, quantity squared, and 5x. So I'm going to multiply this one right here by 5x plus 1 over 5x plus 1. What's 5x plus 1 over 5x plus 1? 1. So I'm just multiplying it by a factor of 1. And that's going to give me, I'm going to have to write over here, but we'll probably get the answer over here to look like it, so I can just use it as 1. That's going to be negative 5 times 6x minus 1 plus 6 times 5x plus 1 over, come on now, quit the sneezing, 5x plus 1 quantity squared. So we still got one more step, and it looks like the x's are going to cancel. Is that right? Yeah, just come on in whenever, that's fine. I'm sorry to be in your way. Looks like the negative 30 plus 30, okay, cancel. Yeah. And then negative 5 times negative 1 is 5. And then 6, so that's 5 plus 6 is 11. Did y'all get 11? Yeah. All right, so I got 11 over 5x plus 1 quantity squared. Now let's see what the quotient rule gives us. The good thing about the quotient rule is it's already got the 5x plus 1 quantity squared, so chances are it looks like to me, I already see the FOIL method over there giving us 30x squared, and this one giving us 30x squared. So I think we're going to see things cancel out. Let's see if I can get it all in this little area. So this is going to give you 30x squared and then that's going to be -5 plus 6 is 1.
No, you're supposed to do the derivative of the.
Oh, I didn't do the derivative. I went ahead and, okay, sorry. So that'd be 5x plus 1 times 6 minus brackets 6x minus 1 times 5, there's our 30s, over the common denominator, and then 30x plus 6, 5x is going to be minus 30x plus 5 over the common denominator, and that is going to give you that because that goes out. What?
It's a masterpiece.
What is?
It just self-love it.
Yeah, that's, but again, this is the funny part. Take your handy dandy green marker. What do those green marks represent? Not just different rules, but what? Which is what class? What class is this? Calculus. That's the only calculus in the problem. You see why people can't pass calculus?
The calculus.
Huh?
So it's not the calculus.
It's not the calculus. Exactly.
Just remember the calculus.
Well, yeah, remembering the calculus and knowing the algebra. All right, first question sent to me from dire needed help. We'll do the product rule first. This problem was sent to me yesterday, and it says, well, I'll tell you what, let's see if I can pull it up in the homework, since I had the homework with, there we go. I think it was the last couple, wasn't it? Miss Branion?
Yes.
Huh.
It's 14 and then it's, I had 6
Oh.
instead of 7 and then it's a couple above that. That one, 11.
This one, okay. It's a little bit different. You mind if I do this one, or you want me to do the one you sent?
You can do that.
Okay. All right, so y'all copy it. Well, I'll just go ahead and do this. Stupid good. Can you do this one 2 ways? Yes, you can. By distributive law, I'm sorry, FOIL, distributive laws, same thing. Or product rule. And we're going to do both. What's the first thing you should do before you start the problem?
Rewrite it.
Rewrite it. Quit. Rewrite or quit. One of those two. Throw your pencil down and make it pop. Takes an art. That's an art, making your pen pop on a notebook paper. You got to do it just right. I'll go ahead and start you off. So the product rule, the distributive, first I'm gonna rewrite it. R of t is equal to t minus e to the t times 5 minus t to the 1/2. And that's rewriting it. You got to do that first. So we'll just kind of mark through that, and we're just going to use this. Got it. Okay, you're supposed to turn. Okay, so over here is going to be R of t is equal to t minus e of t 5 minus t to the 1/2. We'll do product rule here. Can't write this one. Product rule there, and over here we'll do FOIL method first. T t to the 3/2, 5e to the t, and positive et e to the t to the 1/2.
E to the t.
Yep. Sounds funny, but that's it. Now, what's the derivative of 5t? I'll do that one for you.
That has to be plus e to the t, right? You're not.
Negative times negative.
No.
Negative 5 et.
Negative e to the t times 5 is
No, it's
negative.
Christie. The original problem is plus e to.
I'm sorry. I just messed my problem up. So that would be positive 5. Is that the only mess up? No, this would be negative, right? Thank you. Ms. Bowers always thank you, Ms. Bowers. Yeah. There, how's that? Is that better? All right. So this right here is going to be 3 halves t to the negative what? 5 halves. I'm sorry, 1/2. Screwing this off. 3 halves minus 2 halves is 1/2. Hubert, not 3 halves. 5 halves. Plus, actually, this is the same thing because e to the t is what? So don't mess that up, people. And then this, we've got to use what? The product rule, Hubert. That's right. Minus, and then we'll put brackets there. First, times the derivative of the second, times the second, times the derivative of the first. And then you might want to put in your notes, product rule. And the reason you know that is because there's supposed to be a plus in here. This is multiplied. You got 2 terms with exponents multiplied. So this right here is product rule. And that's going to be 5 plus 3 halves t to the 1/2 plus 5 e to the t And then this, you could actually take this down. That's going to be the square root of t. And 2 square root of t and e to the t on top. Minus e to the t over 2 square root of t. Plus e to the t, that's going to be a minus, sorry. Minus e to the t, t to the 1/2. I'm looking to see if there's anything I don't think there's anything I can combine, so I think that's it.
Where did the 1/2 come from in the first, like when you rewrote it in green, why is it t equal 1/2?
It's the square root of t.
I know, but like the first one, why is it t?
That's 2 halves.
Oh, okay.
I did that just to add the exponents.
Thanks.
So we're not going to worry about if it's right or not, because what will the product rule tell us? It'll tell us if it's right or not. Okay? Whatever. Hold on a second. There. All right, so first times the derivative of the second. Well, that's going to be 0 minus 1/2 t to the negative 1/2 minus 1/2 t to the negative 1/2.
What rule is this?
Product rule.
Product rule.
That's a t plus e to t.
Thank you. And that's going to be plus the second times the derivative of the first. And the derivative of the first is what? 1 plus e to the t. Now I'm going to distribute this.
What is that last part?
1 plus e to the t.
Okay.
All right, finish it. Distribute this. And FOIL method there.
I don't know how to distribute that to t. How would you do that?
Well, that's 1t to the first power. So negative 1/2 times 1 is negative 1/2. And t to the first power times t to the negative 1/2, you would subtract 2 halves minus 1/2, that's 1/2.
So 1/2 t.
So it'd be negative 1/2 t to the 1/2 power when you distribute it with the t. Now the only thing you can do with the e to the t is just put it beside it, because you can't combine it. It'd be negative 1/2 t to the negative 1/2 times e to the t.
So you add the exponents.
Okay.
Yeah, or when the bases are the same, yes. So, and what I tell students, I don't care what algebra you're in, I don't care what math class you're in, if you ever get confused, always write what? Your coefficient there and your exponent here. And this exponent's going to be what? 2 halves. Because you're dealing with a fraction right here. Times negative 1/2 t to the negative 1/2. And these two are the same bases. So 1 times negative 1/2 is negative 1/2. And then t to the 2 halves, t to the negative 1/2, you multiply them, so you add the exponents. 2 halves plus negative 1/2 is what? 1/2. Okay? And then, of course, all you can do is put these two together. Now, e to the t is over 1. You can put it up here and bring that radical down because that's going to be a mess. So what I would do is do negative e to the t over 2t to the what? Or 2 square root of t. That's what I would do.
Can you move real quick?
Yeah, move my big head. Okay.
Move to the.
That's t square root of t. Let me rewrite that. What? Now my big head's in your way.
Are you good?
Sorry.
You good?
We're all honest here.
Aircraft head. There we go. Hold on. 2 square root of t. There you go.
I'm not grasping how you got 2 square root of t.
Okay. Rewrite this. Okay, I'll show you right quick. All right, you understand this, right? Distribute that. Got that. All right, now I'm going to distribute that 1/2. But this e to the t, since this is a fraction, I'm going to make this a fraction. E to the t over 1. So plus e to the t over 1 times negative 1/2. And that t to the negative 1/2, I'm going to bring it down with this 2. Because that's, I'll even write that out for you. T to the negative 1/2 over 1. Okay, so that's what we're doing. This times this is right here. Now, I don't like a negative exponent, so I'm going to bring that negative, I'm going to flip this whole thing. I'm going to flip it. And that's going to give me negative 1/2 t to the 1/2 plus e to the t over 1 times negative 1/2 times 1 over t to the 1/2. And what is t to the 1/2? Square root of t. So I can change this to square root of t. And now there's your 2 square root of t. See it? So that'll give us negative 1/2 t to the 1/2 power plus e to the t times 1, and that negative's there, so that's negative e to the t over 2 square root of t. And that's that part. And I remember, there we go. Negative e to the t, 2 square root of t, negative e to the t, 2 square root of t. Let's see if that negative 1/2 t to the 1/2 is over there somewhere. Not yet, but we got this to go. Okay? So what I'm going to do, now that you got that, hopefully, is I'm going to erase all this, and I'm going to put this up here, if that's okay.
be on the video.
Say again?
It'll be on the video.
No. Let me go ahead and take this out. Probably won't even let me move it up. This thing is so cantankerous. Oh, wow. I actually got to move something up without having to go around the world. All right. So that's that. I'm just going to put that in brackets because I want you to know that that is this. Now, we're going to go over to the FOIL method.
E to the t over t's square root of t, right?
Yeah, e to the t. Okay. And then that's going to be 5. Hey, we got a 5. At least we got 2 things, right? 5 e to the t. Negative t to the 1/2. And negative t to the 1/2 e to the t. And of course, what's in front of all that? The plus. So we're going to have negative 1/2 t to the 1/2 minus e to the t over 2 square root of t plus 5 e to the t minus t to the 1/2 minus t to the 1/2 e to the t. Now this right here and this right here, what's in front of this one? 2 over 2, right? Which is 1. And 2 over 2 minus 2 over 2 minus 1 over 2 is what? Negative 3 over 2 t to the 1/2 minus e to the t over 2 square root of t plus 5 e to the t minus t to the 1/2 e to the t. And check that with our previous example. Let's see what we got. Let's use our highlighter. We got our 5. 3/2 t to the 1/2. Uh-oh.
It was messed up in the foil. It should have been negative 3/2.
Okay, thank you.
All the way down.
Where?
Like after 5, it should be minus because when you're blowing it out, it's going to come out
Okay.
negative.
What's up?
It should be negative t to 3/2.
Yeah.
Right here?
Yeah.
Okay, thank you. Glad you caught it. Wish you said something. It's your fault. There we go. Minus 3 halves t, and then negative e. Got that. 5e to the t. Got that. And then negative e to the t times t to the 1/2. Looks like, what's the chances of you getting the wrong answer twice? Very slim. If you got everything the same, then chances are you're what? Correct.
Ready to get rid of that half credit.
Yeah. Miss Brandon, does that help you out? Now, that's only one way to do it. No, did we do the product rule? Okay, we did. We did both ways. I'm sorry. I got lost. Well, when you're thinking about this stuff, you don't think about other stuff. Now let's do the quotient rule problem she sent in. Let me get one like it. The reason I'm doing a different problem is because that gives you another problem of reference, because my problem is not going to be like your problem in the homework. That's why I'm doing it that way. Here it is. Snip. You're supposed to bring enough popcorn for everybody. Yep. I've got that song in my head and I cannot get it out. Whip it good. Weird group in the 80s, Devo. Very weird group. Had pots on their head. They're weird.
What do you do because it's square?
Well, you can do two things. You can bring it up and make it -2 power, do the chain rule, and then do the product rule, or you can do the quotient rule. Chain rule, since you got since like I said, parentheses and an exponent, chain rule. But first you need to rewrite it in which way you want to go. You want to do the product rule or you want to do the quotient rule? I suggest do both. I'm going to put another one over here because I don't like writing on one side and have more on one side than the other. I'm weird. There. I'll give you all a few minutes to do both of them.
If we do the chain rule when I'm multiplying it, do I multiply that t by what's inside and what's in front?
Are you doing the product rule first or the quotient rule?
Quotient.
Quotient rule, then that would be t, or denominator, t minus 7 quantity squared times t, 1 minus t times, yeah, you're going to have to use the product rule and the chain rule on that second part. Well,
do the chain rule first, right?
it doesn't matter. Well, first times the derivative second.
Yeah, which is t
So then you would, yeah,
times,
derivative second, and that's when you use the chain rule.
yeah, and I did
Plus
that.
the second times the derivative first. Derivative first is 1. So
And
write the two ways. You got to rewrite one of them. Bring the t minus 7 quantity squared, bring it up, make it a -2. Now you got the product rule. That's how you can start it with the product rule. And then over here, you can go ahead and rewrite it. I mean, not rewrite it, just do the product rule. So t minus 7 quantity squared times derivative t minus t times the derivative. Yeah, just go get something to drink and I'll bring it back. I mean, that's right.
Oh, no, this is water.
Over t minus 7 squared raised to the what? Second power. And you're going to take the derivative of this, and you're going to take the derivative of this. And this, as Mrs. Stillbrand said, you got to use what?
chain rule.
That means chain rule right there. And let's see, first times the derivative of the second times the derivative of the first. So you don't have to use the product rules.
That's what I'm saying, but after I use the chain rule and I'm multiplying the chain rule by t, do I multiply the t to the two that's going to be on the
Yes.
outside, but
The
not
two.
on the inside?
Well, you can do it later. When you get on down here, you can distribute.
Okay.
You can do it later. It doesn't matter when you do it. And then this, y prime, is equal to first times the derivative of the second plus the second times the derivative of the first. We'll take the derivative here and the derivative here, so you got to use the chain rule here too.
T. I hate that.
What?
There's no escape from the chain.
No, there's no escaping any of them. Unless you want to be Parks and Recreation major. 17,000 a year. What's my second rule? There's always one, but what's the second rule? Nothing's free. And you say, what's that got to do with this? The more you put into something, the more you what? Get out of it. You don't want to take math and science and be a Parks and Recreation major, then don't whine when you make 17,000 a year. I mean, honestly.
Does that include DNR?
I don't know. I don't know what DNR. I think y'all have to take first variable calculus, don't you?
Take elementary statistics.
Well, it's more math.
I was actually going to ask you that.
You got these people whining about financial aid and student loans and all this. Well, I paid my student loan off. Why? I got me a job. How did I get me a job? I got a degree program that hires. I interviewed a woman on TV one time on the news, and she was complaining about student aid and her bills. Well, she was going to Yale, okay, and they asked her what her major was, and she said, female statistics or something. It was female, some crazy major.
Going to Yale, though, you know.
Third rule of life: champagne taste on a beer budget. Wanting to go to Yale, there's people in hell that wants ice water. You go to what you can what? Afford. Hubie went to Tri-County Tech. He could barely afford that. I had $55,000 student loans. I paid it off in 10 years.
Tri-County?
No, Tri-County and Clemson. Tri-County Tech paid for my master's. They didn't pay for it. We got a thing so we could put in for mini grants to go to conferences and stuff, and I put in to pay for my classes, and I only had to pay for my books. So I had to do that every semester. I had to fill out all the paperwork. But they paid for it. I'll give Tri-County that. They paid for it. Foundation did, not state dollars, donation money. And they paid for my 18 hours toward my doctorate, which I don't want to get my doctorate.
No, but it's not that they paid that. Like, how much was it if you were to pay?
It would have been, back then, it was $1,000 a credit
So,
or $500 a credit, one of those two.
so,
So it had been $1,500 or $3,000, one of the two.
and they paid pennies on the dollar for
They paid for it, yeah.
that. Yeah, for pennies on the dollar. They
That
didn't pay
helped me
that
out. But they didn't pay my $50,000 loan off. I tried to apply for one of the Title III things where they pay you for loan. They wouldn't do it here at Tri-County. I tried that too.
You didn't get the GI Bill?
Yeah, I did. I was doing that while I was going to Tri-County. I meant while I was going to Clemson, because I came out. So that helped.
My mom went to USC and just said it was $60 per ounce.
Yeah. Back then, the GI Bill's done differently than it's done now. Now, they give you the whole thing. They didn't do that back then. Back then, the military was thriving and, you know, it was well equipped and everything. And back then, everybody wanted to go in. Everybody wants to go in. The incentives are not that high. When the people are not going in, that's when they make the incentives higher. Therefore, the GI Bill was higher later than it was in the 80s when Reagan was president.
When did you serve?
Served 88 to 98.
How old were you then?
Like
I went
freshman high
in,
school?
I want to say I went in when I was 22 or 24, somewhere in there.
So this was after?
Yeah, after high school. All right. So Y prime, I'd do it again in a heartbeat. Not right now. Until after the election, I would do it. But not right now. There's no way in hell I'd go in the military right now. Let's see. T times, okay, let's do the chain rule. -2 times T minus 7 to the -3. And then what is the derivative of T minus 7?
1.
And then this is going to be plus, I'm going to put this right here in brackets, not for any reason except for you to see that that's that part right there. That.
So you brought the the exponent out front, and then you subtracted 1 from it, and that's the chain
And
rule.
what's inside. Chain rule, the only difference between the chain rule and the product rule, the power rule, is power rule, you just take the derivative, you bring it out, and -1. The chain rule, if you bring it out, you -1, but you have to take the derivative of what? What's inside. And that's why I always told y'all, when we started the chain rule, you got to define what's inside. And what's inside is the T minus 7. Okay? Plus T minus 7 times 1. Okay, I'm writing that small because I don't want to go across that line. So Y prime is equal to, right now, I'm just going to take this 1, this T, and this -2.
Shouldn't that be
Wait,
T
T-
minus 7 to the -2? The second part?
Yeah.
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 Did I not write it? Thank you. Miss Bowers. Miss Bowers, you're going to pass this course with a good grade because you catch my mistakes and you tell me. You don't wait 3 or 4 steps. Okay, thank you, Miss Bowers. T, and I'm going to put that -2 here, and that 1, I'm just showing you that I'm going to pull that, and that all out here. And then that'll give me T minus 7 to the -3rd. And I'm going to put brackets around that because that's still that part right there.
-2t. Sorry, you're going fast.
And plus, I'm going to add this bracket. And that 1 doesn't do anything because it's multiplicative identity, so T minus 7 to the -2 power. Okay. Multiplicative identity, yes. So what can I do with this guy? Well, this is all over 1, so what can I do with that -3? Bring it down, and that'll give me Y prime is equal to -2t over t minus 7 to the 3rd power. Time plus 1 over t minus 7 to the what? 2nd power. Well, we're not going to stop there. Why? Common denominator. Plus, we've got to have a common denominator. So we need to multiply this guy by t minus 7 over t minus 7, don't we? Well, I'm going to stop right here. We're going to go over here and do this. and then we'll do the final answer together and see if it matches up, because I've run out of room over here. So, okay, let's take the derivative. Y prime is equal to t minus 7 times what? 1 minus brackets t, chain rule, 2 times t minus 7 to the 1 times what? 1. Over t minus 7 to the what power? Fourth. 2 times 2 is 4, not 3. Unless you read my writing might look like a 1 or a 2, but I don't know. All right. So y prime is equal to, nothing's affected here because 1's a multiplicative identity, minus a cluster. So I'm going to bring that 2 and that t out front. I'm going to put it in brackets because I don't want to get messed up. Times t minus 7 over t minus 7 to the 4th power. Now, here's an this is an algebraic question. Can we get rid of some things?
Yes,
What?
the T minus.
T minus 7s. Take this one out. I'm going to take my red marker. I'm going to take this one out, and that gives me t minus 7 to the 1st power. Take this one out, that'll give me t minus 7 to the 3rd power.
What did you just do?
Take this one out, and that'll give us t minus 7 to the what? 0 power, which that's 1. All 3 of them are in common.
That's why we get my 3 from.
Okay.
I don't get how you did that though.
They're all in common. I can take them out.
Yeah, so, but the brackets don't change that?
Mm-mm.
So t minus 7, you just take 1
I took
out
one of them,
all-
yeah, 1.
every
Because
single one.
you can take your lowest exponent out. You can factor your lowest exponent. So let's look at the 3 exponents. 4, 2, and 1. I can take out the lowest exponent. And I took them out. So 2 minus 1 is 1. 1 minus 1 is 0. 4 minus 1 is 3. So that gets us to our t minus 7 to the 3rd power common denominator. Now we just got to do the top. And that gives us y prime is equal to t minus 7 and then minus what?
2t.
Minus 2t over t minus 7 to the 3rd power. That is your answer. Of course, t minus 2t is negative t. So your final answer is y prime is equal to negative t minus 7 over t minus 7 to the 3rd power. Ms. Brannigan, did you have something like this at the top with different numbers?
Yes,
The minus t minus 7?
yeah, I just couldn't figure out how to get rid of the 2t, that's what I was.
Yeah. This is a 1 right here. And 1t minus 2t is negative t. Now, how can you get that over here? Well, the common denominator is what? T minus 7 to the 3rd power. You see that over there. So you need to multiply this by t minus 3, or whatever, t minus 7 over t minus 7. And that gives you the common denominator here. But up here you get negative 2t minus what? Or plus 1t minus what? 7, right? And what happens here? You get negative t minus 7. So there's my negative t minus 7 right there. So either way you do it, you'll get the same answer. So Give that to Miss
Continuing
Brandon.
with the product rule,
Say again?
have we continued with the product rule?
Yeah, right here. You gotta get common denominator. Give that to Miss Brandon. You gotta get a common denominator. So what's the common denominator? See, common denominators, you use the highest exponent. Factoring out, you use the lowest exponent. So what's the highest exponent? 3. So we got to make this t minus 7 to square. We got to make it to the third power. So I got to multiply it by t minus 7 over t minus 7 because that's a factor of 1. So 1 times t minus 7 is 1t minus 7. That's what we have in the denominator, or the numerator. 2t plus 1t minus 7 gives us negative t minus 7, which is right here.
So t minus 7 over,
Negative t minus 7 over t minus 7 to the third power. Just like we got right here.
can you back up to multiplying by t minus 7 to try
Yeah,
to
right
find
here.
the same common denominator?
Yeah,
Thank you. So you,
this is to the first power. And what's 2 plus 1?
3.
So that's a common denominator of t minus 7 to the third power.
Okay.
Just write it as 1. Now, if you
Over-
multiply the
over
bottom,
t over t minus 7,
t minus 7 over t minus 7.
but t minus 7 over t minus 7 to the third power plus negative 2t over t minus 7 to the third. Right?
Yes,
You
t
drag
minus
that-
7
Thank you.
over t to the third, yeah.
Okay, so
And then you just do the top. You don't do anything to the bottom. You just combine the bottom. It'll be t minus 7 to the third. Do your math at the top, and you should get this, which gives you that. I ran out of room. I'm sorry.
but how does that equal what we just came up with on the other side?
Hold on. Let me do this because I don't like leaving it like this. Let me.
Negative 2t. Well, just flip it over. So that's
Hold on.
t minus 7 over. I'm missing a negative somewhere. Oh, nope. Drag it. Negative t over.
Okay, look here.
No, I figured it out.
You got it?
Yes, sir.
Well, I still want to add it. Negative 2t over t minus 7 to the third power plus 1 over t minus 7 to the second power. I'm going to multiply this by t minus 7 to the first power over t minus 7 to the first power. The reason I'm putting that 1 is so you'll see that that makes it 3. So that's going to give us negative 2t, and once you got a common denominator, you can put it all over what? One denominator. So that's t minus 7 to the third power. And 2t plus t
Negative.
minus 7, and then that's going to give us,
Negative t minus 7.
yep, negative t minus 7 over t minus 7, oops, to the third power, and that is what we got. That makes me feel better. Okay.
I had to Google that word multiplicative, and it means anything subject to multiplication.
You look that word up. Okay, who's got another question? I got one more for you. And this is a good one because I'll see what y'all do with it.
We just gotta do it a good one.
Huh?
We gotta do it a good one.
Yeah. So y'all's first reaction is going to be, oh my God, I can't do that. Oh, wait a minute. That's not right.
It means technically anything
First
that has offspring
times the derivative of the second.
that has offspring.
There we go.
more than one is
It'll be
by that number.
f of x,
Math.
f of x is equal to 5 natural log of x
That dot right there, they're moving it back
times e to the x. Now, when you first look at this problem, what are you going to say?
Oh, there's a log round. Damn it.
Oh gosh, I can't do it. There's only one step. And if you can do it in your head, there is just one step. Just write the answer. But go ahead and do the product rule and you'll see what I'm saying. Product rule is first times the derivative of the second, so just write it out. I give you parentheses so you can tell which is the first and which is the second.
Who's worse, us or you?
Hmm?
I said, I don't know who's worse, us or you.
I suck.
No, not at all.
I'm a failure. You know where I should be? Living in a ditch. Go to KFC, get me one of those cardboard laptops. Live in a cardboard box. They still have those cardboard laptops that they used to, my kids used to get those all the time. Used to have this meal that was in a cardboard laptop. That was probably, well, that was before my divorce, so that was 4 years ago, 3 years ago, somewhere in there. Huh, you seen them? So I ain't crazy, I ain't making it up. Yeah. KFC has really gone downhill lately. I won't eat there anymore. Yin yang, yin yang.
Is that right?
Oh, yeah.
Ew, don't make that face.
It should be just one step. Yeah. Oh, you've got a common denominator probably. It's only 2 steps. I think. Unless I've done something wrong.
Oh, you just leave it like that?
Yeah. There's nothing, I mean, if you want to get a common denominator, you can.
No,
The whole
what
purpose.
I did is I added that with this and made it 6 here.
That's fine. You can do that. I mean, you can, or you could factor, so you could factor it out.
No, I just
But
want
it'd still be a
which way
mess.
is Easiest, so
That's
that
fine.
I can leave it like that.
The whole purpose of this is to show you that a complicated looking problem can be what? Very simple. First times the derivative of the second plus the second times the derivative of the first. I'll do this one for you. Don't say I don't help you. I'll do this one. 5 natural log of x times what? E to the x. Because the derivative of e to the x, e to the x. Plus e to the x times what? 5 over. Oh. Do you know how I could make $1 million? If I could make this thing operate off of brain waves, then there'd be all kind of squirrelies through up here. Okay, that's it. Now you can do several things with this, but the whole point is you're done.
That's it.
That's it. One step.
You really
Now, what can you do? Well, you can factor out an e to the x. You could do that, and that would give you 5 natural log of x plus 5 over x. And then Miss Hildebrand, what could you do here?
I combined the e to the x's. 'Cause
You
I
could-
have 5 e.
Okay.
Yeah.
You could do that. You could get a common denominator, which would be 5x natural log of x over x plus 5. You could do all kinds of things. But the whole point is I wanted to show you that this problem right here, if I was to put that on the test, I bet 5 of you wouldn't even do it. because you think it's complicated. It's not. Capiche? Now, what am I going to do in the next couple of days? I'll tell you as soon as I stop the, well, I better put it on here for those of you right here.
Sunday, break.
Well, yeah, I was planning on drinking, but I didn't need to be told that. Okay. We are in, technically we're in whatever chapter we're in, 3.6, because 3.6 is just a continuation. So what I'm going to do is I'm going to put some more derivatives on 3.6 and give you a couple of 3.6 stupid book questions so you can say you did something out of this book. And then chapter 3 is over with, so you're looking at a test being posted this weekend or Monday, okay? And I will go over any homework questions you want me to go over Monday. If I don't have any homework questions, then we're going on to unit. Let's take a look at that. Because we got time. I think I got 15 minutes, do I not? Because y'all were like packing up already, and that's rude. I got it right here. Hold on. No, we're going to go on to integrals. Wait a minute. Yeah. The reason I want to go to integrals is because I want to show you right after you got derivatives in your head, okay? You've got the basics. When you finish chapter 3, you have the 4 basic rules, 5, counting the logarithms. You have the 5 basic rules of derivatives. When you get to chapter unit 4, we switch and do the antiderivative. So it's best to do that right after you do the derivatives. And then if we get to unit 3, then hallelujah. But I really want to spend the rest of our time together. How long is that?
2 weeks.
2 weeks on antiderivatives. I really could care less about unit 3. Okay? If I do anything, I might go over a few hot spots in unit 3 and give you a last test on the last day of class with like 5 or 6 questions. Or online, 5 or 6 questions.
Are you meaning that we're skipping unit 4 and going to 5?
No, there's 4 units. The first unit is a review unit. They don't say it's a unit. Unit 1, unit 2, unit 3, unit 4. They're putting all of this on the final exam. We're not doing that. If I do anything, I'll put this on the last day of class. We're skipping unit 4 and going to unit 5. Now, a lot of you say, well, why do you skip unit 4? Unit 4 is just derivatives, more derivatives. The reason I think you should get to unit 5 is because in 230, you're going to need to be able to take the antiderivative backwards and forwards like you can do the derivative. And if you don't have that, you're going to suck. Okay? So that's why we're going to do it. So I need you to put in your notes, we're going to skip unit 4, which is more derivatives, and we're going to pick up next week with unit 5, which is chapter 5. And we're going to spend a lot of time in that chapter. Okay? So look for a test this weekend or Monday. If you don't see it Sunday, do you need to email me and say I haven't seen the test? No, because I might wait till Monday to do it. It's still going to be Monday through Friday or Sunday through Friday, whenever you get it. You're going to have 5 days to take it. It's not a big deal. Does anybody got any questions for me? Monday is going to be a review or the start of unit 5? Yes?
Got a question. So if I took form C of the current test first, would that still?
Doesn't matter. You just took the harder of the 3. That's all. You know, if you like chains and whips, that's fine. That's the way you roll. That's the way you roll, man. I'm kidding. Hold on a second.